When you consume fat, your digestive system begins its work within minutes. Contrary to popular belief, dietary fat doesn't immediately convert to body fat. Instead, fats are emulsified by bile acids in your small intestine. They are then broken down into fatty acids and glycerol by enzymes called lipases. These components are absorbed into the lymphatic system through tiny structures known as chylomicrons. Your body uses these fats for energy, cellular repair, and hormone production. Unlike carbohydrates, fats don't trigger a rapid insulin spike. Insulin is a key hormone in fat storage, and low insulin levels mean less fat storage. So, eating fat doesn't directly make you fat. This biochemical dance challenges everything you thought you knew about dietary fat. Within 30 minutes of eating fat, your mitochondria, the powerhouses inside your cells, come into play. Fatty acids enter your cells and are transported to the mitochondria. Here, they undergo beta-oxidation, a process that converts them into acetyl-CoA. This molecule enters the Krebs cycle, producing ATP, the energy currency of your body. Meanwhile, ketones, another product of fat metabolism, can cross the blood-brain barrier. They provide a steady energy source for your brain, unlike the quick sugar rush from carbs. This energy balance highlights a critical fact: fats are more than just stored calories. They fuel your body in ways sugar never can. This is why fats are essential for long-term energy stability. The belief that fat directly turns into body fat has a historical basis, but it's not grounded in biochemistry. Fats require more metabolic steps to convert into body fat compared to carbohydrates. The liver transforms excess carbohydrates into triglycerides, a type of fat. This process is known as de novo lipogenesis. It occurs when the liver converts sugars into fats for storage. However, this is energy-intensive and not a primary pathway for dietary fat. In fact, a 2010 study in the American Journal of Clinical Nutrition found that only 2% of dietary fat is stored directly. The rest is used for immediate bodily functions or energy. This reveals the inefficiency of fat storage from dietary fat. When fats enter your bloodstream, they act as messengers. They signal the release of hormones like leptin and ghrelin, which regulate hunger and satiety. Leptin is secreted by fat cells and tells your brain you've had enough to eat. Ghrelin, on the other hand, stimulates appetite. The presence of fat in your diet increases leptin sensitivity, reducing your overall appetite. Meanwhile, low-fat diets often lead to leptin resistance, where your brain doesn't receive the full signal. This hormonal balance shows that fats play a pivotal role in controlling hunger. Contrary to making you fat, they help you manage food intake effectively. Understanding hormones reveals why fats are satiating. Not all fats are created equal, and your body knows this. Saturated fats and unsaturated fats have different metabolic fates. Unsaturated fats, like those found in olive oil and avocados, enhance cell membrane fluidity. This improves cellular communication and nutrient transport. Saturated fats, often found in animal products, are more stable and provide structural integrity. However, excessive intake can influence cholesterol levels. A 2015 meta-analysis in The Lancet showed no significant link between saturated fat intake and heart disease. This challenges the simplistic notion that all fats are harmful. Your body uses different fats in diverse ways, each serving specific physiological roles. The type of fat significantly impacts your health, fundamentally altering the narrative. Deep within your cells, the enzyme hormone-sensitive lipase plays a crucial role in fat metabolism. When insulin levels drop, this enzyme activates. It breaks down stored triglycerides into free fatty acids and glycerol. These are then released into the bloodstream for energy. Interestingly, a 2018 study in Cell Metabolism found that fasting or low-carb diets enhance this enzyme's activity. This means your body is more efficient at using stored fat for energy when insulin is low. The presence of hormone-sensitive lipase underscores how your body prioritizes energy use from stored fats. This enzymatic action is key to understanding why fat consumption and storage are complex. In your gut, the microbial inhabitants have a profound impact on fat digestion. Certain bacteria like bacteroids are adept at breaking down polysaccharides, complex carbohydrates, into short-chain fatty acids. These acids influence the amount of fat your body stores. A 2019 study in Nature Microbiology showed that a diverse gut microbiome can reduce fat absorption by 20%. These microbes also produce butyrate, a fatty acid that enhances insulin sensitivity. This interaction reveals that gut health is an integral part of fat metabolism. The relationship between your gut bacteria and fat absorption opens new perspectives on dietary fats and health. It's not just what you eat, but what your microbes do with it. Inside your liver, fats undergo transformation into ketones, especially during low-carb intake. This process, called ketogenesis, happens when glycogen stores are depleted. Ketones, such as beta-hydroxybutyrate, are then released into the bloodstream. They serve as an alternative energy source for your brain and muscles. A 2020 study in the Journal of Physiology found that ketones enhance mitochondrial efficiency. This means your cells produce more energy with less oxygen. Ketogenesis is more than a backup plan, it's a highly efficient metabolic pathway. This liver activity exemplifies how dietary fats can be transformed into powerful energy sources. The liver's role is pivotal in fat utilization, especially under specific dietary conditions. The hormone adiponectin, secreted by your fat cells, plays a significant role in fat metabolism. Higher levels of adiponectin are associated with increased insulin sensitivity and fat oxidation. A 2017 study in diabetes care found that omega-3 fatty acids increase adiponectin levels by 30%. This hormone enhances the ability of muscles to use carbohydrates for energy, reducing fat storage. It also increases the rate at which fats are broken down. The interaction of adiponectin with dietary fats reveals a sophisticated hormonal regulation. This process highlights how specific fats can improve metabolic health. The presence of adiponectin illustrates the body's complex hormonal orchestration in fat metabolism. The endocannabinoid system, primarily known for its role in appetite, also influences fat storage. This system uses compounds similar to those in cannabis to regulate energy balance. A 2016 study in Cellular and Molecular Life Sciences showed that endocannabinoids affect fat cells. They regulate the conversion of white fat to brown fat, the latter being more metabolically active. Brown fat burns calories to generate heat, a process called thermogenesis. This conversion is crucial because brown fat is linked to lower body weight. The endocannabinoid system's involvement in fat metabolism underscores the body's intricate regulatory networks. It highlights how various systems interact to influence fat dynamics. Consuming excessive fat over time can lead to insulin resistance. Your cells become less responsive to insulin, making it harder to regulate blood sugar levels. However, this isn't solely caused by dietary fat. The combination of high-fat and high-sugar diets is particularly detrimental. A 2015 study in the Journal of Lipid Research found that this combination leads to a 60% increase in visceral fat. Visceral fat surrounds your organs and is linked to metabolic diseases. It's the synergy of fats and sugars that amplifies health risks. This interaction shifts the focus away from fat alone, revealing a more nuanced picture of metabolic health. On the flip side, consuming too little fat can lead to deficiencies in essential fatty acids and fat-soluble vitamins. Your body requires fats to absorb vitamins A, D, E, and K. A 2012 study in Nutrition Reviews showed that low-fat diets can reduce vitamin absorption by up to 70%. Without these vitamins, your immune function, bone health, and vision can suffer. Essential fatty acids like omega-3s are crucial for brain health and inflammation control. A deficiency can lead to cognitive decline and increased inflammation. This highlights that dietary fats are not only energy sources but also vital for nutrient absorption. The implications of fat scarcity are profound and multifaceted. Chronic exposure to trans fats, often found in processed foods, does increase health risks. These artificially hydrogenated oils are linked to increased LDL cholesterol levels. A 2013 meta-analysis in the BMJ found that trans fats elevate heart disease risk by 34%. They also promote inflammation and endothelial dysfunction, affecting blood vessel health. Unlike natural fats, trans fats disrupt normal cellular functions. Their impact extends beyond weight, altering cardiovascular health in significant ways. This distinction between fat types underscores the importance of the source and processing of dietary fats. Trans fats reveal how industrial modifications can detrimentally affect health. Some remarkable edge cases show how the body adapts to high-fat diets. The ketogenic diet, high in fats and low in carbs, induces ketosis. In ketosis, your body efficiently burns fat for fuel. A 2021 study in the journal Obesity found that individuals on a ketogenic diet lost 2-3 times more weight than those on a low-fat diet. This diet also showed improved markers for insulin sensitivity and blood lipid profiles. The body's ability to adapt and thrive on a high-fat diet challenges conventional dietary wisdom. It highlights the metabolic flexibility inherent in human physiology. This adaptability offers insights into fat metabolism's complexity and potential. Food companies exploit our cravings by manipulating fat, sugar, and salt in products. This combination triggers the brain's reward center, leading to overconsumption. A 2019 study in Frontiers in Psychology revealed that foods high in fats and sugars stimulate dopamine release. This rush is similar to drugs, creating addictive eating patterns. Yet the surprising truth is that natural fats like those in nuts can reduce cravings. A study in Appetite found that eating nuts decreases snack consumption by 40%. This demonstrates that not all fats are created equal. Understanding this can redefine your relationship with fats and challenge prevailing dietary myths.